Hello, everybody. Welcome to today's lesson. Today we continue our talk about differential. And we will connect the differential with integration. Let's start with an example. This is an integration, indefinite integration. First, I will do this with no differential, without using differential. So the usual way is to expand this because you have a bracket squared. So let's expand it. This is the expansion of the perfect square. Then we can integrate term by term. This integration is not particularly difficult. So you expand it, integrate term by term, this term, this term, this term. Constant can be brought out of the integral sign. Bring the constant out. Bring the constant out. Bring the constant out. Integration dx is just x. Integration this, you use power rule and you get x squared divided by 2. Integrate this, you add 1 to the exponent, so you get x cubed and divided by 3. Simplify this, you get this. Don't forget to integrate the indefinite integration, you need a constant. So that's our result. Nothing to do with differential. Then I give you another way of integrate this. This is called substitution method. So let's repeat this question using substitution. let's use a letter U to represent the inside of the bracket. So let U equals 2 minus 3x. Then, what is du then? Du is d2 minus 3x. And then this is d2 minus d3x. And then this is 0 minus 3. Because if you want to write step by step, you can write this. Move the 3 in the front, and this becomes 3 dx. But dx is 1, so you have minus 3. Oh, no, wait a minute. Sorry, I just made a statement wrong. Dx is just dx. All right. So we have an expression. So minus x 3 dx. This looks like a differential. But actually, I'm not using the differential to do the integration. Let's go on. You will see what I will going to do now. So the original integration becomes u squared dx. But dx is negative du over 3. So I replace this dx by negative du over 3. Continue. Continue again. Then this is the integration with respect to u, not with respect to x. And we can still use the power rule. So n plus 1 divided by n plus 1. So you have u3, and then you need a constant. Now the integration is done. What you need to continue is go back to x. U is this, so substitute that back, you get x. This is 9, okay. So 2 minus 3x. Then you need, you can leave it there, because this is already the answer. You can leave your answer in this way. or you can expand it. It's a bracket cubed. You can expand it. Okay. Okay, that's just one. Okay. So you can expand the cube of the bracket. So you expand this, and then the next is to simplify it. All right. And then the next is to simplify it. Let me erase something. Okay. So this continue is this line. And you rewrite this in terms of 4 terms here. 1, 2, 3, 4. 4 terms. Notice the c is a constant. -8/9 is also a constant. So this constant and this constant can be combined. The result is still a constant. So you just use one constant to represent this plus that. If you want to be very strict, then this c is not the same c as that, So probably you can use C subscript 1 to tell the difference. C subscript 1 is not, negative 8 over 9 plus C. So look at this. This answer is exactly this answer. So you can either expand it or you use substitution and you will get the same result. Of course you will get the same result. So how about my topic today, differential? So how do I use differential to do this? Actually, differential is the same as substitution, except you are avoiding using the letter U. You do not use the letter U, but actually you are doing substitution. Then the writing may be shorter. That's all the differential does. Differential makes the writing shorter instead of write out the substitution letter U. So let's see how differential is used here. We consider the same question, but we use differential. Note, what is the differential of this? So if you want to do the differential of this, then it is just the differential of negative 3x. Now, what I want to tell you the steps is that I multiply negative 3 over negative 3. I multiply negative 3 over negative 3. This is just 1, so I do not change anything. But then I leave the denominator. I move the numerator to inside the integral. I move the negative 3 here. I move the negative 3 to this place. And then I combine the negative 3 with dx. Negative 3 times dx is exactly the same as d negative 3x. Then I do another trick. Inside this bracket negative 3x, I add a constant 2. I add a constant. I can do that because d constant is 0. So I can add any constant. The result is still d negative 3x. So it doesn't affect anything. But why do I need to do that? Because if I add a constant 2 there, this part and this part exactly the same. So essentially, I am doing substitution. You see, this is what we call in the last work, we call u. So I have u squared du. Do you realize that? This is exactly substitution. But I do not use the letter u. I just use the idea of differential. And once I have this, then I can have the same work as before. Then I have power rule. So this, using power rule, I get this. And this is exactly the result of substitution. So I'm not going to continue. It's the same result as before. Do you realize using this is just to save the time to write u? Just to save the time to write let u equals this. Maybe this is not too clear, so let's have more examples to make my point clearer to you. So let's do another example. How do we do this? Using differential? Look, you have a 3x here, but I have only x here. I want 3x after d. So I multiply 3 over 3. But let's not write out 3 over 3. Let me do it very quickly to see if you follow. Let's do very quickly. Okay. I want 3 before x. I want 3 before x. But I cannot just write a 3 before x. I need to divide by 3. so that I am not changing anything. The next step is that I want this part to be exactly this part. So I add a 4 there. Remember, in our discussion of differential, the differential of a constant is 0. So I add a 4. So this is the differential of 3x plus the differential of 4. But differential 4 is 0. So this is exactly this. So I am not changing anything. But the advantage of adding a 4 here, I make this part exactly this part. Then you can use power rule. Rewrite this in exponential form with a negative exponential. So this is, of course, just rewrite this. Once you have this, you can use power rule. Remember, the power rule is not just this. This is a power rule. The power rule. You don't need an x. You can have anything. I can have y. Then I have y here. Yeah? You understand? You don't need x. You need same thing here, x here, or y here, or even u here, or even v here. So now I have here now. I have this to an exponent, and this part and this part are exactly the same. Therefore, I can use a power rule. And this is equal to this plus 1 is 1/2. And you divide it by 1/2. And you add a constant. So this is how I use the idea of differential to do the integration. And then the next step is just to simplify it. So I'm not going to continue because simplify is just a very simple step. Let me give you another example. I want to integrate this. Okay, so how do I do that? Let me use the idea of differential. I separate the sine cube into sine square times another sine. I shouldn't do that. I don't have enough space. Okay. Now you will see the beauty of differential. What is the derivative of cosine? What is this? The derivative of cosine is negative sine. Therefore, in differential form, d cosine theta is equal to negative sine theta d theta. D cosine theta is negative sine theta d theta. That's differential label. Differential. You see, I have sine theta d theta. So sine theta d theta is negative d cosine theta. So sine theta d theta is the negative of d cosine theta. So I put the negative sign in front. So that's the next step. Now, what is sine squared theta? You know sine squared theta plus cosine squared theta is just 1. Therefore, this is 1 minus cosine squared theta. And then d cosine theta. Expand this part. Expand this, you have this. And then you can integrate two terms. The first term is cosine to the power 15, and the second term is cosine to the power 17. And then you see that this is just power rule. So you can do that. All right. Okay, let's continue on this part of the board. And then you have I can do it quickly. Yeah. Let's Let's use power rule quickly. Okay. So I have cosine 60. Minus 18. This is a definite integral, so I do not need a constant of integration. So I just put the lower limit and upper limit to the result, and then I work it out. Pi over 2 is 90 degrees. I put 90 degrees here, 90 degrees here. Cosine 90 degrees is 0. So the upper limit gives you 0. So you only need the lower limit. But remember that when you put the lower limit in, you need to subtract. Then subtract cancels this negative. So what you have is when theta is 0, cosine 0 is 1. So the numerator is 1. So you have the result 1 over 16 minus 1 over 18. And then if you work it out, it is 1 over 144. And that is your result. So you see this integration, we use the idea of differential. Remember, basically, differential is substitution. Except we do not write let something equal something. We do not write this substitution relation. We just directly use the idea of differential, and we can do the integration. So that's all for today's differential lesson. Thank you for watching. We'll continue next time, maybe another topic. Goodbye.